Hello, everyone. My name is Shishir, and today I'll be presenting Gorilla, where we connect LLMs with massive APIs. This is joint work with my collaborators from UC Berkeley and Microsoft Research. So, on today's agenda, first we'll discuss what we think is the future of LLMs and APIs, and then I'll present two key interesting insights that helped us to actually build Gorilla, which is an LLM. And finally, I'll end with a quick demo and show you where we are right now. Okay, so let's get started. Today, let's just take a step back and look at how we interact with LLMs today. So on the slide, on the left-hand side, you see a dime a dozen LLMs, and you as an individual today are going to go and prompt these LLMs, be it OpenAI's GPT, Claude's and Anthropic's Claude, so on and so forth. And then you get a response from this LLM. Now I've shown here as one interaction back and forth, but you could have multiple interactions where you're trying to refine your prompt or you're trying to add more context into your prompt, so on and so forth. But fundamentally, you are at the center of this interaction where you talk to your LLM, get some response, and then the burden lies upon you to now go ahead and then use the responses that you get from an LLM to perform some action on the rest of the world, right? So you go and perform some action, get some response from the world, and then you understand what's going on, and then you may continue with this line of action, or you may go ahead and create more prompts that you want to interact with your LLMs. But fundamentally, you're at the center of this. And this is where we like to see a change. In our vision of the world, what's going to happen is you're going to go on the extreme left side. So as an individual, you're going to prompt the LLM, and it is now the responsibility of the LLM to go and read the state of the world or perform some action on it, get a response from the world and see what's going on, and then relay that back to the user. Right? So you can see this idea by instead of you being the center of the activity where you talk to the LLM and then go ahead, get some response, and then go perform some action on the world. What we want you to do is actually just talk to the LLM and let the LLM deal with all the hard parts of interacting with the world, right? So this is the vision. And to enable this, let's actually try and understand in a grounded example. So we're all interested in LLMs, and one of the key concerns when you're trying to train LLM is to get access to GPUs, which is a very expensive commodity. So let's say as a user, you say, hey, look, I want one 800 GPU in East US. So the first thing that you're going to do is you're going to actually not ask any other LLM, but ask Gorilla, which is an LLM that we train. So you're going to go and ask Gorilla, hey, can I get 800 GPU in East US? And now Gorilla is going to go and read your state of the world. In this case, it's going to be, okay, East US is in Azure. This could be any of the hyperscalers, but try and see, do they have GPU capacity to give it to you? And if they do have GPU capacity, do you have quota to be able to allocate these resources? And if so, it's going to go ahead, allocate the GPU instance for you, and then give the SSH credentials back to you so that you can go ahead and start using this instance. Right? This is one example that Gorilla enables. And like I mentioned, in this case, it would be Azure or any of your hyperscalers. And it's not just infrastructure that we're thinking about, right? The goal is, can you really go and talk to an LLM and then interact with the rest of the world through this LLM? Now, to understand how we do this, let me actually try and explain to you how we came up with Gorilla, right? A few months ago, sometime around the end of 2022, around November, December, when ChatGPT came out, like everybody else, we were also quite excited and some of the early adopters. But soon we realized that chatting is a great demonstration of the technology of LLMs, but it's not LLMs in entirety, right? So LLMs are tools, a powerful tool, but a tool nonetheless. And one thing that we have learned over the years is that tools get more powerful when they are connected with every other tool. And when you can actually use this tool is how you can amplify the capabilities of these tools. So our goal was simple. Can we connect LLM as a tool with other tools? Now in computer science, the way you connect different tools or computer systems together is through APIs. That's a well-defined interface that we have agreed and accepted upon, right? So the idea then was clear. As an LLM, can we teach Gorilla to invoke and call other APIs? Which I'm sure is a domain and a topic that this crowd understands pretty well. And so that's how we went and built Gorilla, where you have a user, he or she may ask a question to the LLM, and now the LLM is going to go and understand what to do, and using APIs interact with the rest of the world. Now, this is best understood with an example, right? So As an LLM, it creates APIs that you can use to interact with the world. Now, once you have this as the backbone, you can think of multiple form factors how you would interact with Gorilla, right? So let me show you two examples right now. The first example is a command line interface. So what I'm going to do is I'm going to go ahead and say, okay, Gorilla, list all my GCP instances. So that's it. I'm going to use the keyword Gorilla and then go and say what I need to do. And then once you trigger this, what the LLM is doing in the backend is trying to figure out what's going on and present you with a list of options that you can choose. So in this case, I'm going to pick the first one. It's going to go ahead, execute this instructions, and then return the response to me, right? So if you think of the big picture that I've shown you before, I asked Gola what I need to do. The LLM went and figured out what needs to be done, gave me the presented the API, and as a security feature, we don't execute any APIs, but we let the user confirm or deny. So once you confirm in this case, we go ahead, execute the APIs, and get the response. And by the way, this is all public. It's not just a demo. You can install it with pip install Gorilla CLI, and it would go ahead and install it for you. Obviously, I've already installed it on this machine. Now, another modality is if you want to use some of the different APIs to get something done, especially machine learning APIs. And the reason we chose this domain and the reason it's so interesting is because there are quite a few machine learning APIs, but they all tend to be very similar. And this is where an LLM can shine, right? Without going into the details, but as one high-level example is, say, you want to do image segmentation. Now, there are so many machine learning model APIs that you can use, some with RESTnet backbones, some with VIT backbones, and so on and so forth. Now, using each one is unique in its own sense, right? If I were to say, hey, I just want to do object detection, I could use potentially any one of the backbones. But if I say, hey, look, it needs to be at least X% at top one accuracy on ImageNet, then you want to go for the state-of-the-art models like VIT. But if I were to say, oh, can I use these models on a Raspberry Pi or your commodity hardware? Then probably not, right? Then you might want to be more conscious and cognizant of, oh, what's the number of parameters, how big the model is. And so in those scenarios, you might want to use YOLO V5 or some of these models, right? So we have some examples here that you can go ahead and choose. So in this case, it's like, look, I would like to translate, I feel very good today from English to French. And then you go and invoke Gorilla API. And then what you get on the other end is the API call. But more critically, we also give you some more context to help you make the decision, right? So this would be like, oh, look, this is a natural language processing NLP translation task. Here's the API call that I want. I'm calling this particular model. My API provider happens to be PyTorch, and here's some sort of explanation to go along with it. And finally, here's the code that you can actually execute in your terminal or even in your Colab and get the response. And you can see how once we have this API as an interface, you can now think of integrating LLMs into your workflows. Where you want to get something done, the LLM gives you the API, you integrate this API into your workflow, and then you execute it to get the response. Right. So hopefully I've now convinced you that you can actually use LLMs today to call APIs, to do discovery of APIs, and then integrate that into your workflows. So how did we do this, right? So what's so challenging? Why can't other existing LLMs, or what was missing? So to understand that, let me go ahead into what I think are the two big questions of this year, probably even next year. The first question is, how do you mix fine-tuning and retrieval? Now, for the benefit of audience, fine-tuning is when you take an LLM before. So this could be like your Llama from Facebook, MPT, Falcon. You might have heard of one or many of these. And then you add more information on top of this, and then you fine-tune the model, right? So that's fine-tuning. Very classical, similar to very classical ML techniques. Retrieval is where you have the LLM. You don't fine-tune it, but if I were to ask it any question, I'm going to go ahead and use a retrieval. This could be a vector DB or any other retrieval mechanism, and augment your prompt with additional information, right? So if I were to say, oh, I need to find out what's the weather today, I'm going to add some additional context saying, oh, Shishir is in Berkeley in the state of California. Can you please give us weather for this particular location? So think of retrieval as augmenting your prompt with more information, but you don't touch the underlying LLM. Fine-tuning is where you have full access to go and even fine-tune and change the underlying LLM, right? So the hypothesis, or the wisdom of the crowd, is that look, fine tuning is used to augment the behavior of the model, and retrieval is used to introduce new knowledge to the model, right? And by fine tuning, here I include techniques like RLHF or even just self-instruct tuning. But what we find is that fine tuning is remarkably effective at both behavior and knowledge, except retrievers are quite inaccurate. And so the solution is to use something that we introduced called RAT, which is retrieval-aware training. Right. So the high-level idea, if there's one key takeaway from the RAT, is the following, right? Can you train the model, fine-tune the model, to either use or ignore the retrieved context, right? And why would you want to do this is because your retrievers are fundamentally inaccurate. Even the state-of-the-art retrievers, the way you look at accuracy for these, or a metric of correctness, is something called recall at k, which is if you give the retriever k chances, can you get it right at least once? So instead of getting you one answer, if you allow it to give you 10 answers, is at least one of them correct? And what we find is that most retrievers are not. So by doing RAT, what we're trying to do is we're trying to ensure that the model is robust to low quality retrieval. So no matter how good or bad your retrieval is, can you train the model to make it robust to your underlying retrievers? So, fine tuning and using retrieval-aware generation are the two techniques that people have been debating. And I don't think this is the right question, asking, oh, should we do X or Y? It's not even do X and Y. It's use X to do Y, right? So over here, you're actually going to use RAG and then fine tune. Now, like everything else, this is best understood with an example, right? So let's take this prompt. A user asks, hey, I'm an engineer at Uber and I need to find an API that can classify pedestrians, cars, etc. from an image of the scene. And you're saying write an API in 1 to 2 lines to call, write a Python program, excuse me, in 1 to 2 lines to call the API in TouchHub. Now, traditionally, what you would do is, if you were to use the retrieval-aware technique, you'd go ahead and give this prompt and generate some RAG context. So this is where you go ask your database, hey, here's what the user has asked. Can you give me some reference APIs that I could probably change or add on to get the response to the user? So in this case, you happen to get hybrid nets as the retrieved API. And then you're now going to go and ask the assistant, hey, can you please use this additional information to answer the user's prompt? And the LLM in this case will say, hey, look, it's going to do two things. First, it's going to determine if the API that you gave it is relevant to the question that the user asked. And this is implicit. It's not going to tell you, oh, this is relevant, or it's not relevant, but it's going to implicitly determine, is this relevant to what the user asked? And if it is, then it's going to use this information, this API that you gave it from the retrieval-aware technique, and then answer the question, answer the prompt, and come up with a relevant API call, right? So here's the API call that the LLM came up with. The LLM in this scenario being Gorilla. And it so happened that this time you called the right API. But what happens if you call the wrong API, right? So what happens if you were to, instead of giving it hybrid nets, if you were to give it over here another API which is not really correct? So, PyTorch fair sequence. Now, this is a language translation API, and you can see how to classify pedestrians or cars, etc. from an image, giving it a reference language translation API is the wrong API. So in this case, the LLM is supposed to implicitly identify that, look, this is not the right API. This is actually the wrong API call. And so ignore this API and use the knowledge that it has from its pre-training and its fine-tuning phase to come up and say, hey, look, I'm going to completely ignore your poor retrieval result and just use the context that I have from my training and tell you, hey, you should continue to use hybrid nets. So this is the high idea. This is a retrieval-aware training that helps us come up with the right API call, even in the presence of inaccurate retrievals, right? Now, obviously, this is generalizable beyond APIs, but I think it really shines in this setting. Okay. So moving on, the next question that we want to try to answer is, how do you measure hallucination, right? So if I were to ask you guys, how much does GPT-4 hallucinate, right? This is pre-recorded, so I can't really see responses, but typically when we ask the same question to ourselves, we found that you don't have a really good answer. You might give me a relative comparison. Oh, GPT-4 hallucinates more or less compared to this other LLM that I know, or GPT-4 hallucinates, maybe, maybe not. But you basically get adjectives. It's really hard to measure. And that's something that we try to do with Gorilla is, can we come up with a number, right? If you cannot measure the problem, then how are you going to solve the problem? So how do we measure hallucination is the question. And to answer this question, we adopt this technique from programming languages actually called abstract syntax tree subtree matching. So the idea is simple, right? Suppose I have an API call, and by the way, it's not lost on me that I'm using a lot of machine learning references because that's what my research is focused on. But this is generalized beyond just Python machine learning APIs to RESTful API calls, GraphQL API calls, so on and so forth, right? I showed you some Bash examples as well. So here in this case, the API call happens to be torch hub load, PyTorch vision densenet 1-to-1 pre-trained equals true. The first thing that we do is we're going to go ahead and build an abstract syntax tree from this API call, right? You can see that pre-trained equals true is slightly in a different shape because that's an optional argument. Python lets you have optional arguments. So if this is a RESTful API call, then your abstract syntax tree would include the URL, the header, and the body. So this would be your complete ASD call. And then since APIs are very well formulated, I'm going to ask a simple question. Is this a proper subset of my API base? All right. Every service or organization exposes a bunch of APIs, and you can only access the service to these APIs. So the question you're asking is pretty simple. Is my API call that the LLM produced a subset of my underlying set of API calls that's universal and exhaustive? And in this case, from the color, you can see that yes, torch hub load, torch vision, densenet 1-to-1 pre-trained equals true is actually a subset of my API calls that torch enables. So this is actually not hallucination. This might be inaccurate, but it's not hallucinated, right? So using this technique, you can actually go ahead and measure hallucination. So to summarize, right now we discussed that, look, retrievers can be inaccurate. How do you still use retrievers and make sure your model is robust to that? And B, hallucination is important for LLMs. How do you measure hallucinations? So using this, let's try to benchmark Gorilla, which is an LLM, just to remind, which can help you call the right APIs. So here's a prompt. The prompt is, help me find an API to convert the spoken language in a recorded audio to text, right? And if you were to ask the same thing to GPT-4, you see that it comes up with a library that does not exist. So this is hallucination. And if you were to ask it to Claude, then it comes up with a library that is not hallucinated, but it's a wrong library for this scenario. And if you were to ask Gorilla, we can actually come up with the right API call that helps you convert the language from recorded audio to text, right? Now, if you know one thing about research is that most examples are always cherry-picked, right? So let's try and see beyond this cherry-picked example, how well does Gorilla perform across a wide benchmark? So, okay, what I have here is accuracy on the y-axis and hallucination on the x-axis. And you want to reduce hallucination, so you want to be on the left side, but you want to increase accuracy, so you want to be on the top. So top left is where you want to be. Now, it's important to note that reducing accuracy is not the same as reducing hallucination, right? So one example is if I were to say, hey, I'd like to receive some money online through an API, then Stripe API is the right API. So if I were to say use Stripe API, if the LLM says use Stripe API, then it's accurate. But if the LLM says, hey, why don't you use this text-to-speech API, then it's not accurate, but at the same time, it's not hallucinated, right? You can think of many text-to-speech APIs that exist. Or for example, if it says use Salesforce APIs, Salesforce probably does not help you receive payments, so it's inaccurate, but it's not hallucinated. But if it says use Berkeley APIs, then Berkeley APIs does not exist, right? So clearly that's hallucination. So that's how you can try to identify that you can be highly accurate, but also highly hallucinating, or, so on and so forth. Now, what this graph shows you is that in the zero-shot setting, where you ask the prompt to get a response, Gorilla outperforms both closed source and open source LLMs, right? So this includes GPT-4, 3.5, Llama, Claude. Now, this is in the zero shot, where if you were to not use a retriever. Now, if you were to introduce retrievers, and GPT Retriever is a state-of-the-art retriever, Gorilla matches, if not outperforms, both closed source and open source APIs, right? Now, on the extreme right is an interesting scenario. Well, you may ask the question, hey, you use GPT Retriever. I tend to use a BM25 retriever. I have this elaborate retriever setup. What if we increase recall at K from recall at 3 to recall at 10? How does it vary? So on the extreme right is an Oracle retriever, which means if God were to give you, hey, this is the right API to use, can you please use this API and answer the user's question, then how well does the LLM perform? Now, as you can see, this is like think of this as the ceiling, right? You can do at best this good. And even in these scenarios, Gorilla matches, if not beats, the performance of both closed source and open source APIs. Okay, so this is how well Gorilla performs. And as a part of our research, we go ahead and we give a lot of presentations. And as I've given a bunch of these presentations, one thing that we have learned is that APIs evolve much more frequently than LLMs, right? So how often does an LLM evolve? Well, you may train an LLM once every year, once every 6 months, maybe more frequently. And training LLM is hard for two reasons. One is the cost. We all understand that. But also B is evaluation. Evaluating an LLM is hard. So every time you evaluate an LLM, it takes you a bunch of time. You need to do a bunch of offline metrics, online metrics, and then you deploy it, right? So in these scenarios, it's not feasible to do like, oh, can I fine tune an LLM daily based on the changes in APIs? So to address this difference where your APIs may evolve very frequently, especially the newer APIs, whereas your LLMs are trained not that frequently, which can lead to this brittleness. What we introduce is the question you want to ask, which is how adaptable is your LLM to test time changes in APIs? What this means is you trained your base LLM, the API evolved. Is your LLM adaptable? Now, because of our retrieval-aware training technique, what we find is that Gorilla is actually quite adaptable to test time changes in APIs. So here's an example. Suppose the user asks, I want to automatically remove the background from an input image. Now the retrieval says, hey, use an FCN REST 50 backbone. And so Gorilla uses this information and comes up with the right API call for the user's prompt. Now it so happens that people who make these APIs might potentially decide to upgrade this API from a RESTnet 50 backbone to a RESTnet 101 backbone, right? Just make it more stronger, which is a very natural evolution of APIs. And as you can see over here, Gorilla is actually quite robust to these changes and can identify and say, hey, look, RESTnet 50 to RESTnet 101, I've seen RESTnet 101 before. This seems like a reasonable API. So I'm going to actually go ahead and acknowledge that this API change might have happened and then use this new information to serve the user. Another example is where you say, hey, look, we have this API call. I want to keep the model similar, but I want to improve the performance of the model. So if we have, for example, engineers at NVIDIA who go and say, look, I can handwrite assembly and optimize this model, then you just have to change the repository from PyTorch Vision to say NVIDIA Deep Learning Examples Torch Hub. And as you can tell, Gorilla is able to even adapt this and serve the API, keeping in mind and being cognizant of the underlying changes in the APIs as well. So in summary, APIs change very frequently, and Gorilla is an LLM that can adapt to test time changes in the APIs, right? So this is the model, and we released the paper and the model a few months ago by now, actually. And since then, we're very happy to see that Gorilla has been very widely adopted. So, on the top left, we have a Discord server, and the user was like, this works pretty well. This is the next best thing to sliced bread, which, as a researcher, is a pretty high accolade one can get. Now, outside of individual users, Gorilla has been in the top of Hacker News multiple times by now. And a lot of people are actually using Gorilla. And on the bottom left side, we have stars. This is a vanity metric, but if not anything, it shows that the open source community is actively adopting Gorilla. Now, more critically for us is a lot of media internationally and domestically, and also a lot of machine learning researchers and thought leaders think that this is or endorse that this is the right step for LLMs and for APIs. So yeah, and on the right hand side, we have a hosted service, which means that today you can try Gorilla in less than 5 minutes, right? So we have a hosted service. If you're familiar with using the OpenAI chat completion APIs, to use Gorilla as a drop-in replacement, where you just hit our small servers in Berkeley, and then we can serve Gorilla. And we are seeing a lot of good traction. A lot of people are using Gorilla both for production and to prototype, and even to benchmark and evaluate. So I would urge upon you to give Gorilla a try, and then give us feedback on how well it performs. Now, this is where we are today, but this is not the end, right? This is just the beginning, and there's actually a bunch of research questions actually that is still unanswered, or we think are open research problems, right? So, and this is like a call to arms. If you guys are interested in this, please reach out. And this, oh, and by the way, in case I haven't mentioned already, everything that we do with Gorilla is Apache 2.0 licensed. Your lawyers are gonna love it. You can use it commercially, and you're not even obligated to tell us or inform us, right? But if you do, please tell us. We'd love to help. But yeah, it's free to use commercially. So what remains, right? One is a lot of things that we did with Gorilla is for a single API call. The API itself might be a meta API call that has a collection of APIs underneath, but fundamentally it's one API call, and then your user has a question, can you use an LLM to come up with the right API call? But it gets even more interesting if you have composable API calls, right? It's like, oh, get a request from this user, and then based on this request, do Y. Now, this is challenging because when things go fine, it's fine. But what do you do when things fail, right? For example, if a Stripe API fails, you can't just redo it, right? Because then you're charging the user twice. Whereas then, what's the right fallback mechanism? On the other hand, if you're trying to download something from the internet, if it fails, try again. Well, do you try again, or do you use a different mirror? So the fallback mechanisms for different APIs is actually quite different. And understanding that is critical, and teaching the LLM to understand that, hey, look, there are different APIs. That failover mechanism may be quite different depending on the scenario they're in. So that's still open research questions, right? And we're actively trying to tackle that. The second, and more critically, is that who maintains state and how do you maintain state, right? One example is to say, if the user says, hey, start my GPU VM in East US, and if the user says, shut down that instance, what is that referring to, right? Especially what if this happens to be spread across some time? How do you maintain state? Is the LLM going to maintain state? Are you going to teach your LLM to read the state from the world? Is the world going to maintain state? So these are interesting questions. It's quite abstract, but it's because the nature of the APIs is so diverse. But still, we need to address this to make it a system that can truly interact with the world over perpetual conversations. And last and finally is executing APIs, right? And we all know that there's so many parameters, a lot of environment variables, a lot of permissions, firewalls, etc. Today, we give the API, and we expect the user is going to do the last mile, which is verify the API and execute it, which is great because you get an additional layer of security. There's nothing going on in the background. It's only with the user's explicit consent, that you're going to execute the APIs. But you can imagine that in a few years, LLMs are going to be invoking and executing APIs by themselves. So in those scenarios, what's the ecosystem look like? What's proper sandbox where these LLMs can execute these APIs? So that's also, we think, an open research question. But yeah, but this is quite exciting, and solving this will actually unlock the next paradigm where you can have LLMs just talk to each other and talk to the world, and you as a user is only going to look at the end state and either accept it or reject it, so on and so forth. Okay, so to conclude, what I showed you is a technique or a recipe where you can train an LLM to actually invoke APIs. And we're machine learning researchers, so we start off with TensorFlow, TorchHub, and Hugging Face APIs. But then we had a vibrant Discord community where we got a lot of feedback that, hey, this is not the APIs that most people use. So since then, we have expanded our basket to include more APIs. And this includes Kubernetes, all the hyperscalers like AWS, GCP, Azure, Stripe, and a lot of Bash and Linux commands like awk, sed, so on and so forth. And our next plan is to also include Salesforce and ServiceNow and Datadog APIs. But yeah, it's an ongoing open source effort. I urge you all to come check it out. And if you have any feedback, we'd be more than delighted to work and explore new interesting research ideas. So yeah, thank you very much.